Kia ora, and welcome to this video on using the acid-base solution simulation by PhET. So we start with the introduction, and notice we have a container of water where we have equal amounts of hydronium and hydroxide ions, because water, although most of it consists of water, as we see in this graph, most of it is water, we have a tiny bit of dissociation. And we can check the pH, it is 7, because we have equal amounts. What happens with a strong acid, a weak acid, a strong base, and a weak base? So we can explore these choices, which I would like you to do. So if we have a strong acid, notice that we have no acid left. The HA has completely dissociated to form the anion and the hydronium ion. And we can show it with the molecules. Notice there's no gray. A weak acid, by contrast, though, doesn't have complete dissociation, so we use an equilibrium arrow because only some of it dissociates and they can combine to go back and so on and so forth. So we have a lot of undissociated weak acid with only some hydronium ions with the anion. What happens with a strong base? Notice with the strong base the pH goes up, and again we've got no gray base left. It has completely dissociated into the cation. It's normally a metal cation, that's why it's an M there, and the hydroxide. And because we've got lots of hydroxide, it's a high pH, compared to a weak base where we don't have as much hydroxide, so the pH drops a bit, but it's still above 7, and we have, again, lots of undissociated base. Explore this using the graphs, and you can explore these as well. You can use universal indicator. Notice that in NCEA New Zealand, we use green for the pH of 7. So we have a slightly different color range. And later on in this lesson, you will be exploring the conductivity. Right, you can also go to My Solution and change it. So we can, for instance, see what happens when we have a particular concentration, what happens when we change the concentration. Again, you will explore this later on in this lesson. Notice also with a weak acid, you can change the strength of acid. Notice how I make it go stronger and stronger, more and more of the acid dissociates. But even if I make it a fairly strong weak acid, I still have some undissociated weak acid. If I change this to strong, notice I don't have a sliding scale anymore because strong is strong. It can't go more to completion than completion. If it's completely dissociated, it is completely dissociated. And again, you can explore using with the graphs what happens when you change all this around. And you can explore with the base as well. So have fun. There will be questions, so explore this. Make sure you understand what is the difference between a weak and a strong acid and a weak and a strong base. Goodbye.